Hello. The goal of this is to just help us review for our quiz that is coming next week. So I'm just going to kind of work through all of these different examples and talk through them. You should have tried them all first before coming here. And then once you have tried them, if you want to hear the explanation, then you can kind of fast forward to whatever problem you would like. So here we go. Number one, we're going to raise everything to the second power. When I raise the x to the second power, I'm going to multiply those. So when I do -3 squared, I get 9 and an x to the 8th. This next one, t cubed times t to the first power, I'm going to go ahead and add the exponents to get t to the fourth power. For the next one, I'm going to raise each thing to the power. So it's going to be 3 to the -3rd and 4 to the -3rd. But then I'm going to say, wait, I can't have negative exponents. So I'm going to circle the negative exponents and I'm going to move them. So it's going to become 3 to the positive third in the denominator and 4 to the positive third in the numerator. And then I'm going to calculate what each of those are. So it's going to be 64 over 27. For my next one, I have 4 c's in the numerator and 6 c's in the denominator. 4 of them are going to cancel out. I have 2 left over, but they're left in the denominator. So it is 1 over c squared. Or you can subtract your exponents. You get c to the -2nd and move it down to the denominator. You'll get the same answer. For number 5, I'm going to raise everything to the -2nd power. So I get c to the -6th over c to the -14th when I multiply those. I'm going to say there's no negative exponents, so I'm going to circle them and move them. And then looking at this, 6 c's would cancel out, and I would be left with 8 overall, and they would be in the numerator. For number 6, I noticed that the 2 over 4 reduces to 1/2. I also noticed that I have x's and y's that need to move. So what I'm going to do is I'm going to leave the ones alone that don't move. So the 1, the y, and the 2, those stay where they are. The x squared is going to move down. The y squared is going to move up. And the x cubed is also going to move up to the numerator. So move things around, and now what we can do is we can take and we can combine things. So in my numerator, I have 3 y's. In my denominator, I have a 2. And then as for my x's, I have 2 that would cancel, and I would only have 1 left over in the numerator. And I can kind of make that look a little bit nicer. So y cubed x over 2. For number 7, I'm going to take a to the 4th and a to the -4th, and I'm going to move it to the denominator. The b stays where it is at, so it's b over a to the 4th and c to the 6th. For number 8 here, I'm going to raise everything in the numerator to the 3rd power. So I'm going to write out 2 cubed, a to the 6th, and b cubed. In the denominator, I'm going to raise everything to the 2nd power, so it's 2 squared, a squared, and b to the 6th. I'm going to go ahead and figure out what 2 cubed and 2 squared are. So that's going to become 8 and 4. For my a's, I'm going to cancel 2 of those out. I'm left with 4 more, and the extra 4 are in the numerator. For my b's, I'm going to cancel 3 of those out. I'm left with 3 more, and they're left in the denominator. And the last thing to do is 8 divided by 4 is 2. So I'm going to reduce that. It's going to be 2a to the 4th over b cubed. For number 9, I'm going to go ahead and I'm going to multiply across the numerators and across the denominators. So I'm going to do 2 times -30 and get -60. X times x gives me x squared. And y to the 4th times y gives me y to the 5th. I'm going to multiply across my denominators. 2 times 5 is 10. X times x squared is x cubed. And y squared times y is y cubed. Then I'm going to take and reduce 60 over 10 is going to become just 6 over 1. So I'm going to have -6 in the numerator. For my x's, I have 1 left over in the denominator when 2 of them cancel out. For my y's, you can subtract your exponents, or you can say 3 cancel out and you're left with 2 and you're left with them in the numerator. Okay, number 10 has a lot going in it. So I'm going to look at my first fraction and I'm going to take care of anything that has a negative exponent. Notice I am leaving the negative 5 alone because the 5 is negative, but it's not a negative exponent. So the negative 5 and the y to the fourth stay in the numerator. X squared stays in the denominator. And then I'm going to move y to the first power up and x to the third power down. Then in my second fraction, I'm going to go ahead and raise everything to the third power in the numerator. So 3 cubed x to the sixth, y to the sixth, over x cubed y. Now I can simplify a little bit. My first fraction is going to be negative 5 y to the fifth when I add them over x to the fifth. For my next one, I'm going to do 3 cubed as 27. For my x's, I have 3 x's left in the numerator when I cancel things out. And I have 5 y's left in the numerator, so I have nothing really in the denominator for that one when things cancel out. Then we're going to multiply across. So we're going to do negative 5 times 27, and that's going to be negative 135. I have 3 x's overall, but 10 y's overall. In my denominators, I only have 5 x's. And the very last step is to simplify anything that has the same base, so that's those x values. So 3 x's cancel out. I have 2 left over in the denominator, and the 135 and the y stay where they are. For number 11, we're going to go ahead and we're going to raise everything to the negative second power. So negative 2 to the negative 2, a to the negative 4, b to the negative 2, and c to the fourth. I have to raise everything in my denominator to the negative second power as well. So 4 to the negative 2, a to the negative second, b to the negative fourth, and c to the eighth. So that's step 1. Step 2 is anything that has a negative exponent, I'm going to circle and I'm going to move. So I still have the c to the fourth up top and c to the eighth down low. The things that are moving down are the negative 2 now squared, a to the fourth, and b squared. The things moving up now are going to be 4 squared, a squared, and b to the fourth. Now I have a little bit of cleaning up to do. I'm going to go ahead and simplify my numbers. So 4 squared gives me 16. Negative 2 squared gives me a positive 4. And then I have a squared b to the fourth, c to the fourth, over a to the fourth, b squared, and c to the eighth. Now I just have to take and reduce my fraction. So 16 divided by 4 reduces to 4 divided by 1. So I have 4 in my numerator. For my a's, I have 2 extra a's in the bottom. For my b's, I have 2 extra b's in the numerator. And for my c's, I have 4 extra c's in the denominator. So hopefully that helped with all of your different exponent rules. We're going to now move on to the other portions here. So writing the exponential equation. So it's going to be y equals a times b to the x. B is your base. That's what you're multiplying by to get from one to the next. And a is your initial value. And so for this one, your initial value happens when x is 0. So 50 is going to be my a value. My b is my base. That's how I get from one to the next. So to go from 50 to 25, I'm dividing by 2, which is technically multiplying by 1/2. So to write my equation, it's going to be y equals 50 times 1/2 to the x power. For this next section, to know if something is going to be exponential growth or decay, you're going to have to look for the base. So in this equation, the base is always whatever is being raised to the x power. So for the first one, part A, it's going to be 3/4. For the next one, it's going to be 1.6. Any number smaller than 1 is going to make it decay because things are going to get smaller over time if they're being 3/4 of the last one. Anything bigger than 1 is going to be growth because if you multiply something by 1.6 over time it is going to grow. On a table you look at your numbers here, 50 to 25, this is the same example as the last one because we were able to look and see that our base here is 1/2. Since our base is 1/2, we can see that our numbers are decreasing, making this decay. Versus the next one, you can see that your numbers are growing over time, so you can tell it's going to be an exponential growth function. But in order to figure out how much they're growing by, what we do is we take one number, so let's take 18, and you divide by the previous amount. And so that's going to be 3/2. You can test another one. Let's do 40.5 divided by 27. We once again get 3/2. So that's our base for that one. Visually speaking, for E and F, from left to right, if it's decreasing over time, it's going down, it's decay. Versus F, from left to right, it's going up over time, that is growth. Then what we did is we took these different things and we looked at our transformations. So looking at this one, we have lots of different things here. This 2 is our base, which means this is going to be a growth function. The number up with the x, that is your h value, but you're going to do the opposite of that. So your h here is positive 2, which means this is going to go right 2. The number at your end is your k value. Since it's plus 3, that means you're going to go up 3. And then anything out in front, this is your a value. The negative makes it reflect over your x-axis. The 1/4 is going to be your vertical compression. It's compression versus a stretch because it is less than 1. So it's actually going to be like shrinking things by a factor of 1/4. So if you can look at an equation like this and identify all these pieces of information, now we just need to find what matches up with this. We said it was right 2, so it's not left, but it is right. K told us it moved up and not down. A told us this was vertically compressed, not stretched. This was reflected because of the negative. The base made this exponential growth. And the last one is being able to identify your asymptote. Your asymptote is always going to match your k value. So it's going to be y equals 3 for this one. So those are the ones that we should circle. So here's where I'm going to pause. I'm going to make another video going through the rest of the examples, the second half 15 through 21.